Hello, everyone. We're going to go over section 9.1 today. Um, so it's about analyzing graphs of linear relations. So in order to do that, we are going to start by going over how to draw graphs and how to plot points. So the first thing that you need to remember is that the x-axis is the horizontal axis, and that, of course, the y-axis is the vertical axis. So we have what's called an order pair. Will look like something like this right here, 3 comma negative 5. So the first number is always the x value, which is going to be horizontal, and the second value is always going to be the y value, which is vertical. So for the x values, because it is horizontal, if it is positive, you'll go to the right, and if it's negative, you'll go to the left. And similarly, for the y-axis, if it is positive, you will move upwards, and then if it's negative, you go downwards. So for the point that we're looking at, 3, negative 5, you will move to the right 3 spaces from the origin, and then you'll move down 5 spaces in the negative direction. Okay, so just to make sure that everybody is on the same page, we have 8 points right here. We are going to start with point A, which of course is just 0, 0. So here's point A, 0, 0, also known as the origin. So when you hear me talk about the origin, it's always referring to this point 0, 0 here. Next up, we have the point B, which is 0, 3. We're going to start at 0, 0 and move up 3 spaces, 1, 2, and 3. So this will be point B. And then we have point C, which is 3, 7, 3, 1, 2, 3, horizontally first to the right, and then 7 spaces up. So it will be here. Okay, so this is point C. It's going to keep moving on here to point D, 0, negative 6. So do not move left or right. Just go down 6 spaces. 1, 2, 3, 4, 5, 6. So this is point D. All right, and then we have the point E, 5, 0. So we're only going to move to the right 5 spaces. Stop there. We have point E. And then afterwards, we'll have point F, same thing, but we'll move to the left 4 spaces this time. Point F. And then finally, the last couple of points, we have G and H. So G is going to be negative 8. So let's move from the origin, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. And then down 5 spaces. So it'll be here, G. And finally, the last point is H. So negative 4, which we know where that is from F, and then go down 7 spaces. So this will be the point H. So another way that we're going to look at linear relations, we're going to graph them. So that's why we want to review how to use the coordinate plane. Also going to look at table of values. So table of values, quite simply put, is, one second. So we're just looking for the precise definition here. So we have some consistency. Thank you for your patience. So a table of values is a table of x and y values. That's really weird. Now, of course, those would be written as ordered pairs of points on a graph. So for right now, our table values are generally going to show linear relations, but later on, of course, they can show other relations as well, quadratic, cubic, and others. But for now, we're just going to have some linear relations. But table of values is something that you're going to see quite a lot. Now, usually the table of values will be vertical, but to save space here, I just put a horizontal one on this page. So the top row, you can see 1, 2, 3, 4. Those corresponds to our x values here, time worked. So top row will generally be the x values, and the bottom row will be the y values. Okay. So a lot of times what we will say as well is that the x values are the independent values, or that x is the independent variable, and then the dependent variable will be the y values. Now, x and y are just kind of general variables that we use. We can pick other letters depending on the situation. But it is important to note here that the pay is dependent on how much the person worked. So in this case, we will have time. So you might want to use the variable t instead of x, but still put it horizontally, of course, and the units is in hours. Likewise, pay would be the y variable. You might want to use the letter p instead, and that's in dollars. So you can see in this case that 1 hour $12, 2 hour $24. So it looks like the person is getting paid $12 an hour. Now, if you were to use a vertical table of values, then the left column will be the x and the right column will be the y. Okay. So the idea here is we can use a table of values that demonstrates a linear relation as we have here, or we can put it in a graph. So the advantages of the graph is one, it is more visual, and number two, it will be much easier to see patterns. Okay, so let's look on the next example here. We have some notebooks that are being purchased. So you can see that the number of notebooks purchased is the um, independent variable. In this case, we call it n, and the cost is in dollars, and that's the dependent variable, so the y variable, and it has the variable c, capital C. So the pattern that you will notice in this case is, of course, that as the price goes up by 2, the price of the notebooks goes up by 1. Sorry, the price of the notebooks goes up by 2 as the number of notebooks goes up by 1, right? Oops. Okay. Now, the next piece is the cost per notebook. You can clearly see one notebook $2, two notebooks $4. So the cost per notebook is $2. You can tell that from the pattern in the graph. Okay. So then, of course, you can make a table of values. Now, later on, we're going to learn to transform linear relation from a graph to table of values to order pairs to describing it words, which we did in orange just up above, and also with a equation. So that's later on. So notebooks is one of the variables. It is, of course, the independent variable. So that's our x. And the cost is dependent on number of books you buy. So that will be the y variable. So that will be 1, 2, 3, and 4. And then on the right hand side, you have 2, 4, 6, and 8. Now, of course, if there's some kind of price break, right, if you buy 3 notebooks is $1 off, then this wouldn't be a linear relation anymore. So it is important to note. Last little part here. Is it possible to have points between the ones on the graph? So if you look at the graph, in order to have a point in between, you have a point somewhere here, which means you have to buy like 1.5 notebooks, which is generally not advisable. I guess you could do it, but that would be kind of silly. Okay. So you generally won't be able to buy parts of a book. Well, notebook anyways, you might be able to buy a textbook by chapters. Okay. So we have one more example to look at after this one. Oops. Okay. So we're looking at the maximum number of students that is allowed on a field trip based on the number of teachers that are available to supervise. So the 3 patterns on the graph that you will see, the first one you will note is that there's 1 teacher for every 6 students, one teacher, 6 students, 2 teachers, 12, 3 to 18, 4 to 24. Okay. Number 2 is that this graph is discontinuous. Doesn't make much sense to have 1.5 teachers. And number 3 is that this graph is linear. And that is to say that the dots, even though they're not connected together, they form a straight line. Oops. So the next part, you will notice that we are supposed to make a table of values, but in this case, we do not have a grid that's already drawn for you. So you're gonna have to make your own. So it's pretty easy. Draw a horizontal line, vertical line, and then you can choose your own colors, I guess. Maybe green. So X is the number of teachers and Y is the number of students. Now, in this case, usually it's actually the other way around, right? Like you find out how many students you have going on a field trip, and then you figure out how many teachers you need, rather than this way. So your independent variable, you could argue, are supposed to be the other way around, but for now we're just going to leave it as X is the number of teacher and Y is the number of students that they can supervise. And one of the things you can use to do, sorry, use the linear relations to do, is to figure out what happens if the pattern continues. So if you have 8 teachers available, how many students can go? So you have 8 teachers, and you can have a maximum of 6 students. Oops. Per teacher. So you can simply multiply things out. 8 times 6 is 48 students. So, things to think about from today. Number 1 is a review on how to use a coordinate plane, right? How to label points. Number 2, what is a table of values? What makes a relation linear? And whether you should connect points together. So in today's examples, we do not connect the points together. But in future examples, you might want to do that. Now, and then finally, the last little part is to say that we want to um, kind of determine if the pattern continues, what happens. And that's called extrapolation, and we're going to have a separate part on that at a later date. That's it for now. Thank you for listening.